Howdy, AP PreCal. It is Miss Kosh. In today's video, we're going to look at section 2.9. We're going to look at logarithms. Last year I tweaked Mr. Passwater's notes, kept credit for him and for me. I'm almost positive. Well, the only thing that I did this year is I added a few more examples that I want to do with my kids. And so I'm almost positive I have this entire bit in a video from last year. So if you go look at the playlist on logs, you'll find that video. And for the sake of time, I'm not going to work these 2 pages right now. I'm going to just jump to the new stuff this year because I have too much to do. So I'm lazy, I mean efficient. So here we go. I wrote these problems this year, or found them from something. I think they had been on an old practice worksheet we had, but okay. So this first one, I have log base 8 of log base 5 of x equals 1/3. So with this, I can say 8 to the 1/3. I do my I heart log, so you like the little heart. So I have 8 to the 1/3 is equal to log base 5 of x. Well, hopefully you quickly see that 8 to the 1/3 is 2. If you forget though, 8 is 2 cubed. So 2 cubed to the 1/3 power would just end up giving you 2. So 2 is equal to log base 5 of x. 5 squared is equal to x, so 5 squared is 25, and we're done. Okay, the next one, I see 1/3 log base 5 of x, 1/2 log base 5 of 36. So I'm going to take these and make them become exponents. So I have log base 5 of x to the 1/3 is equal to log base 5 of 36 to the 1/2 power. Square root of 36 is 6. I have log base 5 of something equals log base 5 of something, so the somethings are equal. So this becomes x to the 1/3 power is equal to 6. Now we're going to cube both sides so that we just get x to the first power, and hopefully you know that 6 cubed is 216. Okay, the next one, I wrote this one this year. I thought I was being clever. So with this one, I see a log base 3 of x plus log base 9 of x equals 3. And so we don't have a way to work with logs that have a different base, but we do have the change of base property, which lets us say if I have log base m of n, I can change this to log base b of n over log base b of m. Okay, what was on the bottom stays on the bottom, what was on the top stays on the top. That's the change of base property. And so what I want to do is I'm going to give this a base of, there's more than one way to do this problem, but what I think is, well, 9 is a power of 3. So let's write this as log base 3. So let's see if I have enough space. So I have log base 3 of x plus log base 3 of x divided by log base 3 of 9. I did the change of bases, and that's all equal to 3. Well, hopefully we recognize log base 3 of 9 is equal to 2, because this is 3 squared. And so I have log base 3 of x plus, well, if there's a 2 in the denominator, that's like saying 1/2 times log base 3 of x, and that's equal to 3. Well, I have one set of this and then half of that. So when I add those together, I get 1 1/2, or I get 3 halves. So I have 3 halves log base 3 of x is equal to 3. I'm going to multiply both sides by the reciprocal to get rid of that, and then I end up, the 3's cancel, I'm left with 2. I have log base 3 of x is equal to 2. 3 squared equals x, so x equals 9. I thought that was a clever problem. If you found another way to work that same problem, make a video, post it below, show us what you came up with, or attach a picture or something like that. Can you do that? Anyway, or tell me, yeah, there's probably more than one way. I mean, we could definitely change them both to log base 9. What else could I have done differently? I could have made this become the exponent. Then I'd have 3 cubed is equal to x to the 3 halves. What did I just say? 3 cubed. 3 cubed is equal to x to the 3 halves power. And so then I could have I'd raise that to the power of 2/3. Raise this to the power of 2/3, and then that becomes 3 squared is equal to x. Okay, and anyway, I was going to tell you to come up with a clever way to do it and show us, and then I just came up with another one. If you come up with something else, let me know. Okay, this one, we have these two terms that can be multiplied together, and so I get, well, log base 2 of of this plus log base 2. We can squish that together with multiplication. Okay, I'm going to FOIL all in the same step. That gives me x squared. I see a 1x and a 3x. Add those together, I get 4x. I see 3 equals 3. And now it's I heart logs. 2 to the third equals all that mess. So this is 8 is equal to x squared plus 4x plus 3. Subtract the 8, that becomes a negative 5. And I like my 0 there, but it doesn't matter. This gives me, well, a 5 and a 1. So the 5 should be positive, the 1 should be negative. And that tells me that my x values are negative 5 and positive 1. However, we always have to go back and check. If I plug in negative 5, I try and I can't take the log of a negative value, so that is no good. Plug in positive 1, that'll give me something positive, that'll give me something positive. We have to throw away the negative 5, so our only answer is that x equals 1. Cool. Okay, last one. I think this one behaves in a similar way to the previous one. We're going to squish this together though with division. X squared minus x over x squared. Oh, I lied. Plus x is on top, and then the minus x is on the bottom. I heart logs. This to the this equals that. So 1/3 raised to the negative 1 power is equal to x squared plus x over x squared minus x. 1/3 to the negative 1 power is going to be 3. 3 is equal to x squared plus x over x squared minus x. I'm going to multiply both. I could cross multiply is what I'm actually doing. 3x, or multiplying both sides by this denominator. 3x squared minus 3x equals x squared plus x. This is 2x, subtract that minus 2x squared. Did you catch my mistake? Okay, good. 2x times x minus 2. I find that x equals 0 or positive 2, but coming back here, if I plug in 0, I can't take the log of 0, so that would be no good. So we throw that one out. The 2 squared minus 2 is going to be still positive, so we're fine. So x equals 2. Oh, there was the answer. All right, like, subscribe, comment, and let me know how I can help you. All right, go practice.